Go.
Hey guys, so we're going to be starting experiment 3B, or silver decay. The way we're going to be doing that is we're going to be using silver dimes that have been in the neutron howitzer. And so they've been activated, and we'll be looking at two specific isotopes of silver that come from that. We're going to be using our Logger Pro Vernier radiation counter here. It can pick up high radiation beta decay, which is what it's going to be giving off. And we want to make sure that is particularly close because distance does matter, inverse square law, so we will lose it in the air if we don't have it close. So we do have it as close as possible here. And so Dr. Marsh will be grabbing the silver, we'll be placing it in here, and we have our graph here with our y-axis being radiation over time.
And so I'll come over here, just talk about it a little bit more too. The two isotopes of silver in standard stable silver is silver 108 and silver 110, and they have similar, very short half-lives. So this is an experiment that has to be done very quickly. And in fact, it's kind of cool, right? We're genuinely making hot money here at Grove City College. Okay, so we're going to go over to the howitzer. I'm going to put in 4 dimes made of genuine silver. Now notice they're very close to the probe, so our solid angle is roughly 2 pi. Okay.
And we are collecting 0.2 counts per second. So let's increase this here. There we go.
So how many counts do we have there, Mr. Fugate?
Counts do we have? We started out at 429.
Okay, that's not too bad. But you can see that the activity of these is not all that high. So it's a trade-off, right? If you collect under longer data increments or time increments, you have a higher activity per data increment, but you have fewer points. And if you collect for a shorter period of time, you have more points, but you have fewer counts per data increment. So this is kind of a tricky experiment to perform. And you can see that compared to the metastable barium decay curve, this one's got some scatter in it. Now recall that silver 108 and silver 110 are the parent isotopes. Those are the stable parent isotopes. But they absorb a neutron from the howitzer. They become silver 109 and silver 111. And those are the actual isotopes you need to look up if you want to learn about the radioactive properties of those isotopes. So again, a little bit noisy, but you can see the curve decaying down to a pretty small value. What are the values of the activities of those latest points, Mr. Fugate?
Recently we just hit 57.
57, okay. So I'll give you a hint. There will be a very short half-life, and then there will be a longer half-life. Longer, relatively speaking. The equipment, by the way, is the Vernier radiation monitor probe. It's a Geiger-Muller counter, just like the ones that you've used in class, but much newer.
So we've hit 180 seconds. So we have 3 minutes of data here. Let's see what our last one was. So we ended at 45. So we finished counting.
Okay, we're all done.